All right, little review. Find the area of the shaded region. What we have here is we have a rectangle and then a circle we need to cut out. So if you think about this line, oops, never mind. Think about this line right here. That line is also the diameter of the circle. Okay? Which means the radius is 7.5 on the circle. Now, area of the rectangle is length times width. So that's just 15 times 22, which is 330. Area of the circle is pi r squared. So 7.5 squared times pi. I'm just using the pi key. And you get 176.7. If you subtract those two, you get 153.3 inches squared. Remember, area is always in inches squared. Right? Next one, we have a circle. This is 16, that's 16. Okay? Diameter is 32, but we need the radius anyway, so it doesn't matter. So area of the circle is, again, pi r squared. So that's pi 16 squared. So 16 squared times pi, again, I'm using the pi key, is 804.2. Okay. Now the area of the triangle, this is also 16 because it's the radius. So the area of a triangle is 1/2 base times height. Well, that's 1/2 16 times 16. So 16 squared divided by 2 is 128. So if we do 804.2 minus 128, we get 548.2, and that's square meters. Right, similar to last section, except now we have cones. So on a cone, we have the radius of the circle, which is the base, and then we have a new thing called the slant height. Right? Slant has an L in it, so I guess they chose L. Who knows? But the slant height is a cursive L, and that represents the slant height. So if you remember my earlier idea of a guy breaking into a pyramid, first he has to crawl up the side, the slant height, before he drops down to the middle of the pyramid. So in this case, that line on the outside is the slant height. So, again, the formula is, I think I kind of breezed past that, but sorry, it's the area of the circle plus the area of the wraparound, the cone part, okay, pi RL. So, area is going to be pi r squared, and that's going to be 4 squared plus pi RL. So, pi, and then 4, and then 6. Right? So this ends up being 16 pi plus 24 pi, which is 40 pi, and that's an appropriate answer. 40 pi square inches. Or if we multiply it out, we get 125.7. That's supposed to be an N, square inches. Okay? So either one of those answers is appropriate. Sometimes we might ask you for one or the other. You know, this is exact. This is a decimal rounded answer. Now we're talking about the volume of a cone. Okay, now similar to a pyramid, you know, that 1/3 BH, all right? But the area of the base, more specifically, is, you know, pi r squared, right? So similar idea as what we did on a pyramid. So let's do this. So we have our formula. Volume equals pi r squared, so 2.2 squared, times the height, which is 4.5, divided by 3. Pretty basic, okay? And then you're just going to crunch those numbers. And if you crunch those numbers, 2.2 squared times 4.5 divided by 3, you get 7.26 or 7.3 pi centimeters cubed, because we're doing volume. Or if you multiply by pi, you get 22.81 centimeters cubed. Again, either answer is appropriate. Sometimes we might ask you for one or the other. This is a reminder from the last section about the ratios. I bet you we're doing a volume one now. Okay, so A and B are similar. A is a smaller one this time. All right. So we have our two reference numbers of the, wow, I just lost the word, radii. So my ratio, A to B, is 3 to 9, but we always want to make it simplified for easier math, so 1/3. So the small cone is 1/3 of the big cone, okay? But don't just think, oh, I'm just going to multiply 15 times 3. That's not what we're doing. Remember, the volume here is 15 pi, okay? So you can't just take 15 times 3 and go, oh, that's our answer. That's not the answer, okay? It's a very common mistake. So slow down here. Now, remember, we're talking about volume, so that's A cubed over B cubed, okay? So we're going to cube 1 and cube 3. So that's 1 over 27. There's that number we're looking at. Now, what is the volume of A? 15 pi. What's the volume of B? We don't know. So now we're just going to cross multiply and divide. Divide by 1 is really nothing. So 27 times 15 is 405 pi feet cubed. And again, if you want to, 405 times pi itself is 1272.3 feet cubed. Again, one in terms of pi, one not. And here's our last example. Okay. Find the volume of the composite solid. I'll be honest with you, this one visually kind of threw me off at first. But it's basically like a circus tent. So we have our cylinder here. Right? There's a cylinder, and on top of it is a cone. All right? Okay. You may have looked at it, there was no problem, but I personally had a little bit of issue with it. I don't know why. So, we have volume of a cylinder and volume of a cone. So, this is pi r squared h plus pi r squared h, but divided by 3. So in other words, a cone is a third of a cylinder. Okay? 3 cylinders rearranged would make that, 3 cones rearranged would make that, fill that cylinder completely. So my radius is 6 on that and on this. Okay? So it's pi 6 squared. Now what's the height on the cylinder? It's 5. Plus pi r squared, again 6 squared, but this time the height is 4 divided by 3. Okay, so we have 6 times 6, 36 times 5 is 180 pi. 6 squared is 36. Divided by 12 is, so 3 is 12 times 4 is 48. So 48 pi, which gives us a grand total of 228 pi meters cubed, or 716, if I multiply it out, 0.28 or 0.3, doesn't matter, meters cubed. Again, I don't care if you round to the nearest tenth or hundredths. If the instructions don't tell you, just round it to 1. Just do it correctly. That's it.